Alright, hi year 11, this is Mr. Lim here again, and this is going to be another short video on ion formation, so let's get started. Okay, we're going to be learning about how these ions are formed and what's the relationship between magnitude of charge and electrons gained and lost. Okay, so again from last video, when atoms give and take electrons to achieve their full p orbitals, because that's what the goal is, to get the full p orbitals, they give and they take certain amounts per atom. Okay, so depending on what type of atom it is, they'll give and take a certain amount of electrons. Okay, so the number of electrons given and taken must be equal, and we'll get to that later on when we put them together, so we can work out the ratio of atoms to each other as they form ionic compounds. And so the idea is that to work that out then, to make sure that the number of electrons given and taken is equal, we have to know what their charges are and how many electrons they're giving and taking away. All right, so for monatomic ions, that's ions that originate from a single atom, we need to work out the charge, and that's what we're trying to do. So for monatomic ions, to determine the charge of that ion, we first have to work out how many electrons there are given or taken from each atom. Or you can just memorize all the charges of all the ions. Okay, so the idea is that to make an ion, you have to lose or gain electrons, right? We have to work out how many. Best way to work it out is to memorize the list that I've given you. Alternatively, you can work it out the old-fashioned way, which is, what we're going to be going through. This can be determined by their electron configuration. Okay, so we've done all that work on electron configuration, and their position on the periodic table, which hopefully you remember is based on their electron configuration, right? Elements with only 3 or less electrons in their final energy level will lose electrons, those 3 or less, so those 3 or less, and end up with a full p orbital by losing those electrons, and then they have the full p orbital in the energy level below. Elements with more than 5 electrons, right, in their final energy level will gain 3 or less, depending on how many they need, to fill their p orbitals at that energy level. Okay, so what does that mean? If I have an electron configuration, and I'm just going to use the Bohr model for now, 2, 8, 3, that means I'm going to lose all of those electrons in the outermost energy level, which means I'm going to lose 3 electrons. Okay, but if I have 2, 8, 5, I'm going to gain 3 electrons to bring me to 288, which is effectively, remember that third energy level will be 3s, 2, 3p6. Okay, so if they have 5 or more, they're going to gain. If they have 3 or less, they're going to lose. So if I had something like 2, 8, 18, 1, that's just going to lose 1 electron. Okay, if I had 2, 8, 7, it's going to gain 1 electron. Okay, so that's the idea behind how many is in its last energy level. Okay, this value here, whether it's high, we'll gain some electrons, whether it's low, we'll lose some electrons. Okay, so that's that. So the number of electrons gained or lost will determine the magnitude, which is just the amount, not necessarily the charge, whether it's positive or negative. The number of electrons will determine the magnitude. What's the number? All right. If the electrons are lost, the ion becomes positive because you're losing negative electron bits, and it's called a cation. And if the electrons are gained, then it becomes negative, and it's called an anion. Okay. You can also use your periodic table if you remember this list over here. Okay, so group 1s are always +1, group 2s are always +2, group 13s are always +3, group 15s are always -3, group 16s are always -2, and group 17s are always -1. And groups 3 to 12 and 14 can have various charges, so therefore we don't really deal with those in terms of predicting what charge they'll be. All right. So there are polyatomic ions, not to mention transition metals, which have various charges, and for now you should really just work to memorize those charges. Okay, so things like that you've been seeing on the thing, like SO4 2- or ethanoate CH3COO-, those are polyatomic ions, they're more than one atom ions. They have various charges, and really for now you should really try and just memorize all of those. Okay, so that's it. That's how you work out the charge of an atom. I really do recommend that you memorize it, but if you have to, you can use the periodic table and their electron configuration to work out what their charge is going to be. All right, adios.